Hey guys, it's Miss Adelini, and this is a pedigree tutorial. So today we are going to be looking at a tool that will allow us to track the inheritance of traits across several generations. Now we can use Punnett squares, but that only allows us to track the inheritance of a trait from parents to their offspring, not across many generations. First, I'm going to talk about some of the symbols that you might see in a pedigree. Males are typically represented with a square. Females are typically represented with a circle. Pedigrees will track the inheritance of one trait at a time, so any shaded squares or circles are going to be people who have that trait, whereas unshaded squares and circles will be individuals that do not have that trait or are normal. If you see a horizontal line between a male and a female, that means they are married. And if you see vertical lines branching off of that, they lead to offspring or the children of those two individuals. Okay, so there are several types of traits that we can show in a pedigree. The first one is called an autosomal dominant trait. And those are controlled by a dominant allele that's found on an autosome, a non-sex chromosome. You have 44 autosomes in each of your body cells, and you have 2 sex chromosomes for a total of 46. For the autosomal dominant traits, we are going to use the alleles that are listed right here. We're going to use big A to represent the trait because it is a dominant trait, whereas little a will represent the normal allele. In the middle column, we see the possible allele combinations or genotypes. Big A, and big A, little a will give you the trait since it is dominant, whereas little a is the only genotype that could give you the normal or recessive phenotype or physical trait. So if we were looking at this pedigree, which is shown at the bottom left corner of your screen, you see a mother and a father who are married, and they have a daughter and a son. The father displays the trait, as does the daughter, but the mother and son do not. We're going to use Roman numeral 1 and 2 to represent the generations, and then within each generation we're going to use a normal number, 1 and 2, to represent the different people in that generation. So in our first generation, the parent generation, our first individual, the mother, has to have the genotype little a, because she's normal. Her circle is not shaded in, so she does not show the trait. We can say the same for individual 2, the son is going to have genotype little a, because he is normal. Now, the father has to have either big A, or big A, little a. But I can tell you for a fact that the father has genotype big A, little a, because he had to give a little a to his son, in addition to the mother giving a little a to the son, in order to give him the genotype little a, and be normal. So we can say pretty certainly that the father has the genotype big A, little a. The daughter has the trait, so she has at least one big A, but she could only receive a little a from her mother. So she's going to be big A, little a as well. Okay. The next type of inheritance is going to be autosomal recessive. Autosomal recessive traits are also found on autosomes, non-sex chromosomes, but these ones are controlled by a recessive allele. If that's the case, we're going to define our alleles differently in this chart, with the dominant allele big A being normal and the recessive allele little a representing the trait. So our 2 dominant genotypes, big A, and big A, little a, are going to represent a normal phenotype or physical trait, whereas little a is going to represent the recessive trait itself. So we're going to follow the same procedure for this pedigree, assuming that it's an autosomal recessive pattern of inheritance. So the only individual that shows the trait in this case appears to be the daughter, individual 2-1. And because it's a recessive trait, if she shows the trait, she has to have the genotype a. Her parents both have one normal dominant allele, big A, but they each also have to have a so that they can each give a to their daughter. So we call both of those parents carriers for that recessive allele. This baby could have gotten a big A from mom and a big A from dad, or he could have gotten a big A from one parent and a a from the other. So we can't say for sure whether his genotype is big A or big A. So I put both. The last pattern of inheritance that we're going to look at is sex-linked recessive. They're going to be controlled by a recessive allele found on the X chromosome. And just as we talked about in the sex linkage tutorial, if you have a recessive allele on an X chromosome, they're going to show up more in males than they do in females. And that's because males only have to get one copy of that recessive allele in order to show the trait, since they have just one X chromosome. Females have to get 2 copies of the recessive allele in order to show the trait. So this female genotype within our chart, Xa, Xa, is the only female genotype that will give the female the trait. Males, as you can see, this male here has the genotype XaY. He only needs to receive 1 copy to show the trait. In this case, we use X's with superscripts because it's a trait found on the X chromosome. So X big A is going to be normal, and X little a will represent the sex-linked recessive trait. So there are 2 genotypes that'll give us a normal female, X big A, and X big A, X little a. And 1 genotype, X little a, that'll give us a female with the trait. There's 1 genotype, X big AY, that'll give us the normal male, and 1 X little ay that will give us a male with the trait. So we're going to use the same procedure that we did with the other 2 methods of inheritance in order to figure out the genotypes for the individuals shown in the pedigree for this method of inheritance. Both of the females, the mother, individual 1-1, and the daughter, individual 2-1, are going to have 2 X chromosomes, XX. Both of the males, the father, individual 1-2, and the son, individual 2-2, are going to have an X and a Y chromosome. So let's figure out the superscripts, the big A's and the little a's. Now because it is an X-linked recessive trait, and this son shows the trait, I know his genotype has to be X little a Y. This male gets his Y chromosome from his father, and he gets his X chromosome from his mother. So though his mother has 1 normal allele, X big A, she also has to carry the recessive little a, the trait allele, in order to give it to her son. The father does not show the trait, so we know his genotype is X big A Y. He's normal. The only one that we can't figure out is the daughter, individual 2-1. She gets an X big A from her dad, but she could get either an X big A or an X little a from her mother. So she has 2 possible genotypes, X big A, or X big A, X little a. All right, I hope that this pedigree tutorial was helpful, and we will see you next time. Bye-bye.